PreCalc. So we're watching this on Tuesday after the class on the 6th of December. So we'll be solving trig equations using double angle IDs. You saw a little bit on that on the last video. So let's pick it up from there. These can get a little more challenging, so I want to show you how to handle one, all the twists and turns they can take. So you're going to have to follow your mathematical nose. In other words, one step will lead you to what the next step will be. All right, because we're going to use double angle IDs, you have to search for a double angle. Here it be tangent of 2x. So you're going to rewrite that without the double angle in it. And the double angle ID is the one that I saw in most of your comp books this morning. So 2 tangent x, well actually that was Monday morning. So 2 tangent x over 1 minus tangent squared x. So that takes the place of tangent of 2x. This becomes a little bit of a pain to work with, but nothing we can't handle. Alright, so now I like to clear fractions. So always do that when you have an equation. So you have to have an equal sign before you can do that. I do have an equal sign. So when I say clear fractions, I want to get rid of anything that has a denominator. Here's a denominator. I'm going to multiply everything by that denominator. And so I'm going to multiply this term, and this term. And that will clear the fractions. So this times this will cancel the numerator and denominator, and it'll leave a 2 tangent x. This times this is not so nice and sweet. So it's just going to be cosine x times this 1 minus tangent squared x equals 0. Alright, so do you see why I multiplied by this to make it simpler to work with without that denominator? Always use that technique. Now I'm going to see what I can do in here. I'm going to look at this. How about I distribute the negative 2 cosine x times each of these terms. Mathematically, I can't think of a whole lot else to do. So see if that will lead us to the next step. So negative 2 cosine x times 1 and a negative 2 cosine x times a negative tangent squared x gives us a 2 cosine x tangent squared x and equals 0. So what does your mathematical sense of smell tell you to do next? Sniff it out. One thing I see is each of these terms has a 2 in it and 0 won't be affected. What if I divide a 2 every term by 2? So divide this by 2, and again if I have an equal sign and I do it to every single term on each side of the equal sign, that is legit. So I get rid of some numbers there. So tangent x minus cosine, that was supposed to be x, plus cosine tangent squared x equals 0. Alright, so pick a spot where you think I'm going to work at next. I want to get you skilled at that. So where do you think I'm going to go next to work at simplifying this and getting, remember we're solving this. Solving means at the end of the story we want a trig function by itself equal to some number. So I'm not sure even what trig function that's going to be yet. Alright, does your mathematical nose bring you, I keep dropping my variables, that's cosine x there. Does it bring you to this term here? There's not a whole lot we can do with tangent x, cosine x. So let's just go ahead and look at the term here. where I have a cosine x times the tangent squared x. All right there, I'm going to take this value and rewrite this in terms of sine and cosine. Remember that trick when we were solving trig equations more often? Sine, a tangent is sine over cosine, and tangent squared is sine squared over cosine squared. So do you see there's a slight simplification I can make within this term right here. So again, we're not doing a whole lot of changing. So this cosine will cross out one of those. So I end up with a sine squared on the top and a cosine x on the bottom equals 0. All right, so what if I clear fractions again? So looking at that step where I did that in the very first one, do you see what I'm going to do when I say clear fractions? What am I going to multiply everything by? All right, my magic ear hears you say multiply everything by cosine x. All right, so that will get rid of this denominator. So everything gets multiplied by cosine x. Is it just my imagination, or is this getting sloppier as we go? So now we have tangent x times cosine x, oh fun, minus cosine squared x, plus, now that gets rid, this cosine will cross out this cosine. So when I say cross out, cosine over cosine is a 1, so I don't have to write it any longer. The 1 doesn't affect it. All right, so I need some sniffing out again. Well, my eye is being drawn to this term. So I'm going to write tangent as sine over cosine, and that will help that term at least simplify. So do you see, I don't really have a master plan on this. I just look at the line each time and decide what can be done. All right, I think we're making some progress. I think. If this leads to a dead end, I'll delete the video, so you'll never know. All right, I have taught you to always work in one function or another. So because I have sine and sine squared, is there a way that I can rewrite cosine squared in terms of sine? And I hear through my magic ear a resounding yes. Cosine squared, you'll recall from our Pythag IDs, is 1 minus sine squared. But that negative sign stays outside of it and will affect both these terms. And then sine squared x equals 0. So this is looking peachy keen. So distributing the negative sign, negative 1 plus sine squared x plus sine squared x equals 0. All right, sniff it out, mathematical puppies. What am I going to do next? I'm going to combine like terms. These are both the same. What's sine squared x plus sine squared x? 2 sine squared x, and then just writing the sine x and the minus 1. All right, it's time to complete our problem after all that who-struck. All right, but again, each step led me to the next. And we have a situation that should be factorable, and that's what you should be looking to do. So go ahead and try to factor that. The first term times the first term has to give me this term. So it must be a 2 sine x in one spot and a sine x in the other. The last times the last has to give me that. So it's going to have to be -1 and +1, but they're going to add the outer and inner terms. They have to add to give me a +1 sign. So if I put a +1 out here and a -1 in here, do you see the inner terms give me a -1 sign and the outer terms give me a +2. +2 and a -1 gives me the plus sign, so it worked. So now we have the two branches. When two things multiplied together equal 0, either one is, or the other is, or both are. Alright, 2 sine x minus 1 equals 0. That branch leads us to sine x equals 1/2. And to find where that is, we think of the unit circle. Second coordinate is 1/2 positive, so I can look here and here, and that's where the sign is positive. 1/2 over square root of 3 and up 1/2. So right there it happens at pi over 6. And over here it happens as well. And that's 5 pi over 6. And when I want to remember that I don't have to stop there, I could go around and catch the next one. I'm going to say plus 2 pi n and plus 2 pi n to allow me to do that. Alright, this branch sine x equals -1. So that's the second coordinate. I think it only happens at 3 pi over 2 plus 2 pi n. Alright, what do you think of that? Most of our solving trig equations will not be this way, but some of them will. So take courage, you can do it, and I know you can. You've been prepared and well taught, so go forth and solve. Alright, till tomorrow, this class is done. Hope you're not done for. Bye.